Hi everyone, it's Sorkin. Today we have a problem when we are given an integer num and we need to return true if it can be expressed, this integer can be expressed as the sum of non-negative integer and its reverse. If not, then we are returning false. So let's say that we have here 443. It can be expressed as 172 plus 271. Right? So, and in this case, 271 is the reverse of 172. 61 cannot be, so we are returning false. And in this case, we have 181. It is sum of the 140 plus 041, right? And we can have a leading 0 as we have here, so we are returning true in this case. Okay, let's take this example and work on it. So let's say we have 443 and we can express that as a sum of 172 plus 271, right? So what will be our approach? Which algorithm we are going to use in this case? We are going to start from the 1 because it's a non-negative integers, right? And up to our number, whatever the number is given. So in our case, let's say 443, right? We will go until 443, and at each step what we are going to do, we are going to check that the number and its reverse, whether or not it's equal to our target number 443. If it equals, then we are returning true. If not, then we are checking all the way up to 443, and if not, then we are returning false. So for example, let's say that at the number 12 we need to find its reverse, and the reverse of number 12 is 21, and 12 plus 21, does it equal to 443? It's not, then we are going to the next number. And the next iteration, for example, let's say that at 172, we are checking that is it a reverse? So reverse of it, 172 plus 271, is it equal to 443? If in that case, yes, so we are returning true. So what's the time complexity of this solution? So let's first calculate the time complexity of the reverse function. For the reverse function, let's say that we have number of 1, 2, 3, 4, right? And we are reversing that to 4, 3, 2, and 1. So what would be the first step? The first step is here that we are, what we do here? We are taking the modulo of the 1, 2, 3, 4, right? We are taking the modulo of it. So the modulo gives us 4, right? And then at the next step, we are doing what? We are dividing that by 10. So we are dividing by 10, and we are doing that recursively until we get our number 443. So how many times in this case we are doing this operation? We are doing that 3 times. So we are doing that 3 times. So how many times we are going to divide that? How many times we are going to divide 1, 2, 3, 4? We are going to divide that 3 times. So in this case, then our time complexity for the reverse function would be logarithm of base 10 to the nums in the worst case scenario, right? So what does that mean? So what does logarithm 10 base 10 to the nums means? It means that how many times we need to, how many times in this case, right? 10 to the power of which will give us 1, 2, 3, 4, right? It's approximately, it equals to 3, right? It equals to 3, which is our time complexity of our reverse function. So this is the first part. So this is our reverse function. And also we are going to do this reverse operation for each number, right? So for each number, then in that case, our time complexity would be log base 10 of nums multiplied by our number, and this is our time complexity. How about our space complexity? Our space complexity is constant because we are not using any extra space. Okay, first thing that we do here, we are creating a for loop. So we are going to go over our num, right? Starting from 0 up to our number and including that number. That's why we are adding here 1. So and what we do is we are adding that number plus we are reversing that number. So for the reverse, we are creating a variable reversed, and we are reversing the number. So we are multiplying by 10, and then we are taking the modulo modulo of 10, and then we are dividing by 10, right? So for example, let's say that the 1, 2, 3, 4. So for example, for this case, 1, 2, 3, 4, the first one is that we are going to multiply. So the first one is when we start, the reverse equals to 0. So 0 multiplied by 10 gives us 0, and we are taking the modulo of 10, which gives us 4. So we are taking 4 and dividing by 4. Then we are doing that for 1, 2, 3. So 1, 2, 3. 4 multiplied by 10 gives us 40, and the modulo of 1, 2, 3 gives us 3. So and we are recursively this way, we are reversing it until we have our full reverse number. So, and we are checking that if our reverse number and our number is equals, if the sum of it is equals to num, then in that case we are returning true. If none of the numbers in this range from 0 to our number is in the number and its reverse, some of those are not equal to our num, then in that case we are returning false. So in Java, the solution is identical. So what we do, we are starting from 0 all the way up to our number and including that number. That's why we put here less than or equal to num. So we at any step, we are checking that if our number and its reverse, the sum of it is equals to num. If it equals to num, then we are returning true. Otherwise, we are returning false. For the reverse function, what we do is we are creating a variable reversed, and until our x is more than equals to 0. So what we do, we are multiplied by 10 and adding the modulo of x at the modulo of x, and then we are dividing that by 10 and returning our number after exiting this while loop. So that's it for today. Also, I have the solution in JavaScript, Go, C++, and Scala. I'm going to add them in the description. If you like my content, please hit the like button and subscribe my channel. See you next time. Bye.